right, now we're going to continue our review for the Unit 4 lecture exam and Introduction to Geology, and we want to go over lesson number 19, Global Change in the Earth System. So this lesson is all about environmental geology. How are humans affecting the planet, and if we are affecting it in a bad way, then what can we do about that? So here is the lesson objectives for this lesson. And then you should be reading chapter 19 out of your textbook. And so this first part, I'm not going to emphasize it very much. So you should be very familiar with how did the Earth evolve, and then how did the Earth get its oceans and atmosphere, and then how did life develop on Earth, and then mass extinction events, when did they occur? So all of these are things that do not repeat themselves. So it's a one-time event. Similarly, we're not going to talk about the movement of the plates very much. We've already covered that in plate tectonics. But that is a cycle, which means that the plates come together to make a supercontinent, and then the plates separate again. And then the sea level does change. For example, when you have an ice age, and we know that we have had ice ages every 100,000 years ago, every 100,000 years for the past 1.6 million years. And so every time there's been an ice age, it has withdrawn water from the oceans, and then that has lowered the level of the oceans. We've already talked about the rock cycle, so how one kind of rock can be changed into another kind of rock. And we've also talked about the hydrological cycle when we talked about climate. Where does water come from, and where does water go? However, I do want to emphasize the carbon cycle. So the carbon cycle is going to be, where does carbon dioxide come from, and then where does it go? Okay, so we're going to say that carbon dioxide originally is going to come out of volcanoes. Now also carbon dioxide can come from the impacts of comets and meteors on the Earth's surface, but we're not going to take that into consideration. Another source of carbon is going to be power plants. So let's put a little smokestack there. So power plants and cars also produce carbon dioxide, and also animals. So anything that respires is going to produce carbon dioxide into the atmosphere. So what happens to this carbon dioxide once it gets into the atmosphere? Okay, it can be washed out of the atmosphere by rain, and then when it rains, it can, this water that is loaded with carbon dioxide could hit the ground, and it could go underground, and it could dissolve limestone to make caves. Another thing is it can rain on the oceans, and then it would go to the bottom of the ocean floor to form limestone. So most of Earth's carbon dioxide is locked up in the form of limestone. Okay, but then this limestone lithosphere could be subducted. So let's assume that this is the continent, and then this part of the lithosphere is subducted back underneath the continent. Then as it gets hotter and hotter, then the carbon dioxide will be released, and it can come back out the volcanoes again. Also, you have trees. So anything that photosynthesizes will absorb carbon dioxide. And also out in the ocean, you have algae that would absorb carbon dioxide. So notice that carbon dioxide can go into the atmosphere and carbon dioxide can be pulled out of the atmosphere. So this is going to be very important when we talk about climate change. So carbon dioxide is a greenhouse gas, and it can hold in heat and make a planet hotter. So we will get to that in just a moment. Alright, so now we want to talk about how humans have affected the planet. So the most important one, in my opinion, is going to be population growth. So humans use resources. So the more humans there are, the more resources they're going to use. Also, humans pollute. So the more humans there are, the more pollution there's going to be. And so this graph here shows how human population has exploded, so that for tens of thousands of years, the population of the Earth was in the millions, and then when you got into the 1700s is when it really took off, and you have this exponential increase in the population. So this is a very serious problem, and unless we get a handle on population growth, then that is going to interfere with any plans that we might have for reducing pollution or climate change or any of these other problems. Unless we can fix the population growth thing, those other problems are just going to get worse. Okay, so some other things that humans do is they modify landscapes, like for example paving over areas, and then once an area has concrete on top of it, then water cannot get into the ground underneath it, and so it causes flooding problems, for example. Modification of ecosystems. So this bottom picture here shows what happens when people go in and they cut down all the trees for agricultural purposes. That interferes with any natural ecosystem that might have been there before. And then also, once the trees are cut down, the soils are not that good, especially down in the tropics. And so once those soils have used up all of their nutrients, then they're basically not useful for anything anymore. Okay, loss of biodiversity. So this goes hand in hand with the loss of the ecosystems. So once you start destroying ecosystems, then animals and plants and other kinds of life forms begin to die. And so in the 20th century and the 21st century, there has been a larger than normal loss of biodiversity. Okay, then you have pollution. So humans pollute the land, the water, and the air. Now this is one area in which humans have done a much better job. So starting in the 1960s, a lot of laws were passed in the United States that curtailed the dumping of garbage in the oceans, also the dumping of raw sewage into rivers, and then the belching of smokestacks with pollutants. So these things have been cleaned up quite a bit, at least in the United States and Canada. Okay, then you've got acid rain. So acid rain is going to be what happens when you mix carbon dioxide plus water. So when you do that, that makes carbonic acid. It's a very mild acid, but it can, for example, destroy statues that are out in the rain, or headstones, for example. It could also take the paint or dull the paint on your car, repeated acid baths. Also, you have sulfuric acid is a result of mixing water with sulfur dioxide. So that's another kind. Then you can also have nitric acid, which is a result of mixing nitrous oxide with water. So these are all different kinds of acids that can be formed. And so, but again, this is an area that at least in the United States, we have a better handle on it. So for example, on our cars, we have catalytic converters which help to reduce the amount of pollutants that are coming out. On our power plants, we have scrubbers that removes the amount of carbon dioxide being produced by a power plant. So this is something that we are making strides of. Okay, then you have the ozone depletion. So in the stratosphere of the Earth is the ozone layer. And ozone is going to be O3. Okay, then what ozone protects us from is ultraviolet light. So when ultraviolet light comes in, it's going to split the ozone into regular oxygen, so the stuff that you breathe, and then also oxygen. And then what can happen is they will go back together again to make ozone, but it will release heat, infrared light. So ultraviolet light, which is dangerous, comes in, and what is released is infrared light, which is ordinary heat. Now the problem, though, is CFCs. So a CFC is a chlorofluorocarbon, and so the chlorine part is the bad part. So chlorine is a very reactive gas, so that when these pollutants get into the stratosphere, it will destroy ozone. And one molecule of CFC has the ability to destroy 1 million molecules of ozone. And so without the ozone, then it's not going to protect us from the ultraviolet, and it can cause skin cancers and cataracts. So this is another area that we have made great strides in. So in the United States, we got rid of CFCs, and we now have a different kind of chemical that is used in air conditioners and in plastics that is less damaging to the ozone layer. Okay, let's take a break. When we come back, we are now going to talk about climate change.